Good afternoon, dear students. Yes, so in our previous class, we have started with the classification. Okay, so we have seen the class and phenols, right? We have seen the different classification. Okay, first was based on the number of OH groups and based on the type of hybridization, right? Then we have discussed about what are allylic alcohols. Then we have discussed about what are benzoic alcohols, and then we have discussed about what are vinylic alcohols. Can anyone tell me what do you mean by vinylic alcohols? Yes, what do you mean by vinylic alcohols? What do you mean by vinylic alcohols?
In this alcohol, the OH group is directly attached to a carbon-carbon double bond.
Yes. So the your vinylic alcohols, right? Okay. So then, what are allylic? Yes, allylic alcohols. Allylic. So allylic means like alcohols. In this, we attach to a sp3 hybridized carbon, which is next to a carbon-carbon double bond, right? And what is vinylic? Vinylic is what? In this vinylic, the OH group is bonded directly to the CC double bond. Okay. So this is the meaning. Then we had started with the nomenclature, right? Next we had started with the nomenclature. So we have seen some of the compounds. Okay, how to write the common name and IUPAC name of those compound. Then we have also seen the how to write the names for the cyclic compounds, right? Okay, so now we have left with phenols. Okay, how to name the phenols. So let us see how to name the IUPAC, how to give the names to the your phenols. Okay, so according to common system, when you have a common system, so first the parent member of the family is phenol, right? The parent member is the phenol, and the other names. Okay, so if there are some derivatives of phenol, then they are called as, so other members, they are called as the derivatives of phenol. Okay, now, suppose if you have, now this is what this is called as a phenol. Okay, so OH group is attached to a aromatic ring. So this is called as what? This is called as a phenol, right? And if it is a, if there is a substituent, okay, if there is a substituent on the OH, that is your phenol group, then it is called as what? So you have to see the position. Okay, so and you know that two and five position, they are called as ortho position. So this is a orthocresol. Okay, the name is orthocresol, or the other name is 2-methyl phenol. So this is a common name. Okay, 2-methyl phenol. Then next is this particular compound where you have a OH group and CH3 at the third position. So what is the name? It is a 3-methyl phenol. Okay, it is a 3-methyl phenol, and the compound is metacresol. Okay, the compound is metacresol. Okay, so the next is OH and CH3 at 4th position. So the common name is 4-methyl phenol. Okay, 4-methyl phenol. What is IUPAC name? Yes, what is IUPAC name? The IUPAC name is, it is a paracresol. Okay, paracresol. Then when you have OH and OH, so it is catechol. Okay. Then when you have OH and OH here, and this is called as benzene or phenol. Okay, or it is called as benzene 1,3-diol. Okay, so at 1 and 3rd position you have OH group. Then the last compound, when you have OH and here one OH, it is what? Hydroxyquinone. Okay, hydroxyquinone. Okay, or it is benzene 1,4-diol. Okay, so this is the naming of phenol. So like this, you name the phenol. So phenols, okay, they are so parent member of the family is the phenol, and the substituents will be the derivatives of phenols. Okay, so like this, you are going to name the phenols. Okay, next we are going to see the structure of functional groups. Okay, let us see the structure of functional group. Okay, so here you can see the structure of functional group. So they have taken a methanol. Okay, C, H, 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 and O and H. So this is a CH3OH. So it is a methanol. Okay. So what you can see in this methanol? So okay. So alcohols. So this is a alcohol, right? So in this alcohol, your CO bond. How the CO bond is formed? This particular CO bond. Okay, let me highlight it with red color. So the CO bond, it is formed by overlap of, okay, overlap of sp3 hybrid orbital, sp3 hybrid orbital of carbon, okay, with sp3 hybrid orbital of oxygen. Hybrid orbital of oxygen. So like this, the overlap is formed. So the overlap, the CO bond, how it is formed? It is formed by the overlap of sp3 hybridized orbital of carbon and the sp3 hybridized orbital of oxygen. So like this, the overlap is formed and the bond is formed. CO bond is formed. Okay. Then when you see this COH angle, okay, the angle which is made by CO and H. Okay, COH, the angle made by COH. So this particular angle, okay, this is 108. It is 108.9 degree. So this is slightly angle is 109.28. Okay. So here you can see that the angle is slightly lesser than your tetrahedral angle. So what is the reason? It is due to the presence of the lone pair of electrons. Okay. So because of the repulsion which is experienced by this OH group, okay, between the lone pair of electrons on the on your oxygen. So because of that, the angle is slightly lesser, okay, as compared to your tetrahedral angle. So due to the repulsion between these electrons, okay, due to the repulsion between these electrons. Then when we consider now phenol, okay, let us consider now phenol. So in phenol, what is present? If you consider a phenol, okay, so in phenol, this OH group, okay, the OH group is attached where? It is attached to a sp2 hybridized carbon, right? It is attached to a sp2 hybridized carbon of an aromatic ring, okay? So the CO bond length. So what is the CO bond length? The CO bond length is 136 picometer, okay? And it is slightly less. So this is slightly less than that of your methanol. So here you can see that in this case, how much is the, it is 142 picometer. Okay, the bond length is 142 picometer. That of the, your phenol is 136 picometer. So in case of your phenol, the bond length is lesser as compared to your methanol. Okay. So what is the reason? What is the reason why the bond length of CO that is in the S as compared to that of your methanol? So here the sp2 hybridization of carbon, okay, it becomes more electronegative. So because of the sp2 hybridized carbon, okay, it is having a double bond. So because of that, it becomes more electronegative. Okay. Then second condition is that the CO bond, okay, it will. So because of the presence of this aromatic ring, okay, because of the presence of aromatic ring, you can see that there will be a partial double bond character developed at this CO bond, okay, because there is lone pair of electrons on the oxygen. So this lone pair of electrons, it will undergo delocalization with the your benzene ring. So this is the reason, okay, why the bond length of your phenol is less as compared to that of your alcohol. Understood? Yes. So this was the structure of your functional groups, that is phenols and phenol and alcohol. Okay. So ether we are going to discuss later after completing this two. Okay. So the bond length is how much? It is 136 picometer. Okay. So one reason, first reason is what? Due to the sp2 hybridization of carbon. Okay. So it becomes more electronegative. It becomes more electronegative. And the second condition is that because of the partial double bond character. So partial double bond character, uh, or you can say partial double bond, because of partial double bond. Okay. What happens? Bond character, all right. CO bond. So lone pair of electrons, lone pair of electron of oxygen with benzene ring, with benzene ring. Okay. So partial double bond character. So the CO bond length. So the lone pairs which are present on these electrons on the oxygen, it will become in delocalization or conjugation takes place. Okay. It undergoes conjugation or delocalization of electrons with the help with this benzene ring. So these are the two reasons. Okay. So the so structure is very important. Structure. Okay. Fine. So these are some of the common alcohols, okay, and their names. So primary alcohols, you can see, go through this chart. So these are alcohols, okay, primary alcohol. So these are primary alcohol. These are the secondary alcohol, and these are the tertiary alcohol. So these are some of the list of alcohols. Please go through it. Okay. So further, moving forward. So okay, so this we had discussed about the phenols, right? So the OH group, you can see how the OH group is linked to the carbon. Okay, it is carbon by sp2 hybridization. So the CO bond length is 136 picometer in phenols, okay, which is slightly less than that of methanol. What is the reason? So you can note down this important things, okay. So the reason is it is due to the partial double bond character because of the lone pair of electrons or of the unshared pair or lone pair of electron which the oxygen, it comes in conjugation with this benzene ring. Okay, so because of sp2 hybridized carbon, okay, to which the oxygen is linked. So this is the structure of your phenol. Is it clear? Okay. So structure of ethers. Okay, let us discuss it once only when we are going to discuss the all part. Okay, so today we will just see what we will see the alcohol means we'll first start the alcohols and phenols. Okay, once we complete alcohols and phenol, then we will see ethers. Okay, so let us start with the methods of preparation of alcohols. Okay, so let us start with the methods of preparation of alcohols. So the first is from alkenes. So first method is you can prepare the alcohols from alkenes. So it will undergo a acid catalyzed hydration. Acid catalyzed hydration means what? What is the meaning of this acid catalyzed hydration? Hydration means what? Hydration means adding water molecule. Okay, adding of water molecule. Okay, and acid means what? Presence of in presence of acid. Okay, so acid reaction means what? The acid catalyzed reactions or acid catalyzed hydration means the addition of water molecule, okay, to the alkene take acid. Okay, so now here we take a alkene. So here we have taken a propene. Okay, we have taken prop 1 in, right? So prop 1 in, propene has been taken. Now this to propene, we are going to add a molecule of water in the presence of acid. So which is the acid we are taking? We are taking the dilute H2SO4 acid. Okay, dilute H2SO4 acid. So this will provide H plus ions. Okay, now what reaction? So how this reaction takes place? Yes, we are adding the water molecule to the reactive alkene. So alkenes are highly reactive. Okay, so the water will add across the double bond. So how this addition takes place? Okay, so the addition of water molecule in the presence of acid. Okay, and this acid, it acts as a catalyst. So how does this acid act as? It acts as a catalyst. Okay, and How does the addition takes place? How will the addition takes place? So acid catalyzed reaction. So just now I have explained you what is acid catalyzed reaction, hydration. So addition of water molecule in the water molecule takes place at this this what double bond. Okay, you have a active reactive alkene. Okay, so addition of water takes place in the presence of dilute H2SO4. So what we are going to see here, yes, it will follow a rule which is called as a Markovnikov rule. What it is called as Markovnikov's rule. Okay, Markovnikov's rule. So what does this Markovnikov rule state? So whenever you have so water will split into OH and H plus, right? So OH and H plus. So what will happen? The negative part will be added to the hydrogen. Negative part will be added to the carbon, which is having which is having least number of hydrogens, and the hydrogen will be added to the carbon having uh, more number of hydrogens. So now here, so what we are going to do, we are going to add the water OH to this carbon, and the H will be added to this carbon. So it will result into your propanol, right? Propane to all. So this is a propane to all. So this is a alcohol. Okay, we get what? Alcohol. So acid catalyzed hydration reaction takes place like this. So acids, that is alcohols, can be prepared by treating the alkenes with the water in the presence of acid as the catalyst. Is it clear? Yes. Is it clear? So this was a reaction. So if you want to see commonly, now suppose you have like this. Can you give me the answer? What will be the answer here? So this is alkene. You have water molecule. You are going to add it in the presence of acid. What will be the product?
Alkane.
Yes. How alkane? We are preparing alcohol, not alkanes. Just now I've told you. Water is added across the double bond. So how we are going to add? You have you have a symmetrical alkene. Okay, so the number of hydrogen atoms or number of carbon atoms on either side is the same. So what will happen? So either of one carbon, what will happen? Your hydrogen will add, and on another carbon your oxygen, or that is your OH molecule, will add. So you will yield what? You will yield the alcohol. Is it clear? Yes. So like this, okay. So like this, you will get the alcohol. Okay. So acid catalyzed reaction, it takes place. So whenever you have symmetrical alkene, so addition can takes place anyhow. Okay. Because the number of carbon atoms will be same. But whenever you have unsymmetrical alkene, as in case of here, okay, unsymmetrical number of carbon across the double bond are not same. Here you are 2, here 1. So that time what it will follow? It will follow Markovnikov's rule. Okay, it will follow Markovnikov's rule. Okay. So this was the this. Okay. Next is hydroboration oxidation. Next reaction is hydroboration oxidation. Okay, so let us see what is hydroboration. So we are going to take diborane. Okay, we are going to take a diborane, that is B2H6. What we are going to take? B2H6. And this B2H6, we are going to react it with what? We are going to react it with the alkene. Okay, we are going to react it with alkene. It will give you trialkyl borane. Okay, it will give you trialkyl borane. Okay, and this trialkyl borane, this on oxidation. So what you are going to do? You are going to do oxidation. You will get hydrogen boroxide. Okay, you will get what? Hydrogen boroxide. Hydrogen boroxide. Okay, and this in aqueous NaOH. This in aqueous NaOH will further give you alcohols. This will give you alcohol. So this is the reaction. So B2H6, okay, it can also be taken as BH3 twice. Okay, BH3 twice. Right. It can also be written like this. If you take BH3 and twice. Right. So this is a diborane. So what we are going to do, we are going to take alkenes. We are going to treat it with diborane. When you treat it with diborane, what you will get? Trialkyl boranes. Okay, this trialkyl boranes, you are going to further oxidize it. Okay, you are going to get, okay, you are going to, what you are going to do, oxidize it to hydrogen boroxide. This on further treatment with sodium hydroxide will give you alcohols. Okay, so this is the reaction. So you have to remember the reaction, hydrogen, hydroboration oxidation reaction. So let us see how this reaction takes place. So let me write it here. So I'll take propene, okay, CH3, CH double bond CH2. So I take a propene, okay, propene. This is a alkene, right? Propene. This propene, I'm going to react it with what? Borane, that is BH2. Okay. So we are going to treat it with a diborane. So BH3 twice. Okay. Now this, what will happen? First, you will get a trialkyl borane. So I'll get trialkyl borane. So I'll get CH3. Okay. Then CH2. Then CH2 and BH2. Okay. Now this, what I'm going to do? I'm again going to treat it with a molecule of propene for the further till all these hydrogens are replaced, okay, with the boron. So till that, you are going to take 3 moles. So again, I'm going to take one propene, CH3, CH double bond, CH2. Now what I'm going to get? I'm going to get CH3, CH2, CH2, okay, and BH, and BH. So one of the hydrogen is replaced by what? It is replaced by your this. So it will be 2. Okay, 2. 2 molecules. Now further again, I'm going to treat, there is one more hydrogen, right? So again, I'm going to treat it with a alkene, that is propene. Now what I'm going to get, I'll write it here. So CH3, CH2, CH2, thrice B. Okay, so what I got? I got a trialkyl borane. What I got? I got a trialkyl borane. Now this trialkyl borane, what I'm going to do? I'm going to do oxidation. Okay, we are going to do it oxidation with a H2O2. Okay, we are going to take hydrogen peroxide and NaOH. Okay, this further, what I'll get? I'll get CH3, CH2, CH2OH. Okay, 3 molecules plus BOH thrice. Okay, so this is our what? This is our hydroboration oxidation reaction. So what we are doing? We are taking 3 molecules of alkene. We are going to treat it with diborane. Okay, then it is going to give you a trialkyl borane. This further, we are going to treat it with hydrogen peroxide in the presence of NaOH. You will get a alcohol and okay, alcohol and a byproduct of boron. Is it clear up to here? Okay, fine. So this is a hydroboration oxidation reaction. Okay. Now in this reaction, what it involves the addition of water, okay, into the alkene. So, and this will Okay, so this will be hydroboration oxidation. So what we are doing, we are adding, what we are adding, we are doing a boration reaction. We are taking a diborane followed by a oxidation reaction. So oxidation, we are going to take what? Hydrogen peroxide. Okay, it is a good oxidizing agent. Plus, we are going to take the NaOH. Okay, so we are undergoing a hydroboration reaction on a alkene. So first, it will give you a addition product followed by a oxidation. Okay, you will get your alcohol. Fine. So this is the reaction. So here you can see the addition of borane to the double bond takes place in such a way that the boron gets added to the sp2 carbon with more number of hydrogen atom. Okay, so it will follow anti-Markovnikov rule. It will follow what rule? It will follow anti-Markovnikov rule. Okay, so let us go further. So these were the two reactions from alkenes. So we can prepare our alcohols from alkenes by these two first reaction. First is what? First was by acid catalyzed reaction, hydration reaction, and second was from by hydroboration oxidation. Okay, by hydroboration oxidation reaction. Okay. Next is we are going to see the preparation of alcohols from carbonyl compounds. Next is from carbonyl compounds. So first is by reduction of aldehydes and ketones. First is by reduction of aldehydes and ketones. Okay. So let us see. So aldehydes and ketones. Okay. They are reduced. Okay. You can do a reduction. Okay. You can reduce it to primary alcohols. Okay, so aldehydes will yield primary alcohols and ketones will give you secondary alcohols. Okay, on reduction. So if you take aldehyde, okay, so there are different reducing agents. So different reducing agents like your hydrogen in presence of nickel. Okay, hydrogen in presence of nickel, then platinum or palladium catalyst. Okay, so these are the different reducing agent. Then you can also take sodium in presence of alcohol. Sodium in presence of alcohol. So this is another. Then next is lithium aluminum hydrate. Okay, and sodium borohydrate. Lithium aluminum hydrate and sodium borohydrate. Okay, so these are the three different your what uh, catalyst. So any catalyst you can use. So how you can do reduction? So these are the different reducing agent. Okay, by making use of this, you can do the reduction. So if I take aldehyde, suppose I take a aldehyde, so I'll write generally. So this is the general formula to write the aldehyde. And I am going to do reduction. You know, reduction is addition of hydrogen. Okay, so we are going to add hydrogen in the presence of nickel. So what will be my product? Yes, can anyone tell me what will be the product? What will be my product? It will be CH2OH. So I'll get a primary alcohol. What I'll get? I'll get a primary alcohol, right? What I'll get? I'll get a primary alcohol. So this is the first reduction reaction. So if I take a aldehyde and if I do reduction, what I'm going to get? I'm going to get a primary alcohol. Secondly, if I take a aldehyde, that is ketone. So let us take a ketone. I'm going to do what? Again, reduction in the presence of hydrogen in the presence, or I can take next one more. Okay, I'll take lithium aluminum hydride. So lithium aluminum hydride is a good reducing agent, but it is a costly reducing agent. Okay, the cost is too much. So what I'm going to get? I'm going to get CHOH R dash. So this is what? This is a secondary alcohol. This is what? This is our secondary alcohol. Okay. So if I take aldehyde and if I don't, and if I do reduction, I'll get what? Secondary alcohol. Is it clear? Yes. So let us take example. Is it clear up to here? Okay. So let us take example on this. So let me take acetaldehyde. Okay, acetaldehyde. So I'm going to treat it with H. Okay, that is I'm going to do reduction in the presence of H2 in the presence of platinum. Okay, tell me the product, and one more I'll take. Yes, can you tell me the product obtained here? Here it will be CH3, CH2OH. Okay, and here it will be CH3, CHOH, and CH3. So this is the product obtained. Okay, so this is propane to all, and this is ethanol. Okay, so these are the reduction of carbonyl compound. So reduction of aldehyde yields to primary alcohol, and reduction of ketones will yield you a secondary alcohol. So this is acetone. So from acetone, I'm going to get what? Propane to all, and from acetaldehyde, I'm going to get what? I'm going to get ethanol. Okay, so is it clear? Okay, so next we'll see Next, we will see the reduction of carboxylic acids and esters. So next reaction is by reduction of carboxylic acid and esters. So carboxylic acid, what are carboxylic acid? RC double bond OH. Okay, this is a carboxylic acid. So this carboxylic acid, they are reduced to primary alcohol. What you are doing? You are going to reduce it to primary alcohol. You are going to reduce it to what? Primary alcohol. So this is a primary alcohol. So I'm going to do the reduction on the alcohol acid. So this is a carboxylic acid. Okay, I'm going to do reduction on this carboxylic acid, and I'm going to get a primary alcohol. And what reducing agent I have to use? I have to use a strong reducing agent. What I'm going to use? I'm going to use a strong reducing agent. So which is a strong reducing agent? So I can use lithium aluminum hydride. Okay, lithium aluminum hydride. So we know that lithium aluminum hydride is a strong reducing agent. Okay, it is a strong reducing agent, and what it will do, it will reduce the carboxylic acid to primary alcohol. Okay, so acetic acid giving you alcohol. So if I take CH3, CH2, COH, okay, and I treat it with lithium aluminum. Yes, what product I'll get? Can anyone tell me? CH3, CH2, CH2, OH. Right. So I'll get a propanol. I'll get what? I'll get a propanol. Okay, propane all. Fine. Propane one all. So now here you can also say that instead of using lithium aluminum hydride, so this lithium aluminum hydride, it is very costly. Okay, it is very expensive. It is very, very, very costly. Okay. Now this, instead of using lithium aluminum hydride, there are different this also what reducing agent like hydrogen in platinum agent. It will not convert your acid directly to alcohol. What it will do, it will convert the acid, carboxylic acid, it will be converted to esters. Okay, it will be converted to esters, and then it is reduced. Okay, then it is reduced to your alcohol. Okay, so this is the process. So if you are making use of the other reducing agent, then you have to follow a long step. So by making use of lithium aluminum hydride, as it is a strong reducing agent, so directly our acid can be converted into alcohol. Right. So we can make use of other reducing reagents also, but they are not like they will not give you yield properly. what the products fall will be more. So from carboxylic acid, it has to be what converted to ester. Then from esters, it has to be reduced, and then you will get a alcohol. So it is a tedious process. It is a long process. So instead of that, we are making use of lithium aluminum hydride. So carboxylic acids are directly converted into a alcohols. Okay. So lithium aluminum hydride, it is a strong reducing agent, but it is very, very costly. Okay. So this is the reaction. Okay. So how that will undergo? Suppose I have a carboxylic acid. Okay. Then I'm going to treat it with what? I'm going to treat it with a alcohol. Okay. In the presence of concentrated H2SO4. So acid and alcohol will form what? It will form a ester. It will form ester. Okay. Now this ester I'm going to reduce. Okay. In the presence of hydrogen and nickel. So what I'm going to get? I'm going to get a alcohol CH2OH, and I'm going to get one more alcohol. So I'm going to get a mixture of alcohols. I'm going to get mixture of alcohols. Suppose same, I'll take acetic acid. So tell me if I take example. So this is generally, if I take acetic acid, RsCH3, what will be the product obtained? And here I'll take methanol. Okay, methanol in the presence of concentrated H2SO4. Yes, can you tell me the products? So here it will be CH3, C double bond O, O, CH3. So I'll get a methyl acetate. Okay, methyl acetate. Now this methyl acetate will further undergo reduction in the presence of nickel, hydrogen and nickel. So what I am going to get? I am going to take CH3, CH2OH plus CH3OH. So here the breaking takes place. So here your OH group will be added and here H will be added. Okay. So like this is your mixture of alcohols obtained. Is it clear? So from this tertiary alcohols cannot be obtained. Okay, by reduction of carbonyl compound. So remember that primary from aldehydes you will obtain primary alcohol, from ketones you will obtain secondary alcohol. But tertiary alcohols cannot be obtained from reduction of your carbonyl compounds. Remember that. Okay. Tertiary alcohols cannot be obtained by the reduction of carbonyl compound. Is it clear? Yes. Is it clear up to here? So we have seen the two preparations from alkenes, that is acid catalyzed hydration. Second was hydroboration oxidation. Then we saw from carbonyl compounds reduction of aldehydes and ketones. Okay, and reduction of carboxylic acid and ester. Okay, okay. So yes, so this we have seen just now. So Grignard reagent. So what is Grignard reagent? Let us see what is Grignard reagent. So Grignard reagent. Okay, Grignard reagent. So what do you mean by Grignard reagent? So Grignard reagent, okay, it is a organometallic compound. So it is called as a organometallic compound. Now what is that organometallic compound? It is RMgX. Okay, RMgX is called as a organometallic compound. So Grignard reagent or organometallic compound. So RMgX. Okay. Now, Grignard reagent, if we heat with aldehydes and ketone, it will yield alcohols. It will yield what? Alcohols. If I take a aldehyde, okay, if I take a aldehyde and I react it with Grignard reagent, I'll get what? I'll get a secondary alcohol. I'll get a secondary alcohol. And if I react the Grignard reagent with ketones, I'll get a tertiary alcohols. I'll get a tertiary alcohol. And if I react the Grignard reagent with your formaldehyde, okay, that is your formaldehyde, where your, okay, it is a aldehyde, but your R should be what? R should be H only. If it is R is H only, then what you will get? You will get a primary alcohol. Okay, so these are the three conditions. So this we will see the first the general reaction. Okay, and then the examples we will see in the next class. Okay, so let us see. Suppose, so I have a carbonyl group, I have a carbonyl group, and I have a RMgX. Okay, I have a RMgX. So what will happen? What will happen? So this will be partial positive, this will be partial negative. Okay. So it will tend to pull the electron towards itself. So this R will attack the carbonyl carbon, and thus it will polarize this bond. And what you will get? You will get a complex that is CH. Okay. Then you will get R will be attached here. O, okay, then Mg plus X. Okay, now what will happen? Now here we are going to do hydrolysis. Okay, I'm going to do hydrolysis, that is acid catalyst hydrolysis. So H2O in the presence of H plus. What I'm going to get? So R, your OH will be added, and your MgX and OH will be added. So like this. So this is the mechanism. Is it clear? So what we are going to do? We are going to react the Grignard reagent with a carbonyl compound. So I have taken in general carbonyl compound. So this is the product obtained. So this is across here we are adding H plus ion, and here we are adding OH minus ion. So here at this position. Okay. So what is happening? The R is attacked at this carbonyl carbon. The polarized bond takes place, and the this is the product obtained. Okay. So this is an unstable product. It is an intermediate or unstable product. Further on hydrolysis will give you respective alcohol and the byproduct. Okay. Is it clear? So the examples on that. So okay. So when you react it with a formaldehyde, what you get? You get a primary alcohol. If you react it with aldehydes, any other aldehydes, leaving your R is equals to H. Okay, leaving this any other aldehydes, it will give you secondary alcohols and ketones. If you react with ketones, you'll get a tertiary alcohols. Is it clear? Very important. Very important from exam point of view. It is asked for 3 marks. Okay, it is asked for 3 marks. Very, very important. Mark this as important. Is it clear? Yes. So again, once in the next class, I'll discuss about the Grignard reaction. So remember, so we have seen 4 reactions. First is acid catalyzed hydration. Second was hydroboration oxidation, that is from alkenes, 2 preparations of alcohol from alkenes. Then from carbonyl compounds, we have seen 2 preparations. One was by reduction of alcohol, your aldehydes and ketones, and second was from your this reduction of carboxylic acid and S2. Is it clear? Yes. Grignard reagent. So I've discussed in general. So again, tomorrow's class, I'll discuss it again. Okay. Fine. Any doubts up to here? Any doubts you have? Here. Okay. So we'll discuss about this things in the next class. Okay. About Grignard reagent. So I'll stop it here. So because it will take too much time here. Okay. So what we'll do? So Grignard reagent. So it should go in a flow. Okay. Again, half it will be incomplete. So it is okay. We are going to see the reactions with your formaldehyde, aldehyde, and one ketone. So how respective alcohols are formed. So that let us see in the next class. Fine. So thank you. Okay. Thank you, dear students. So I'll be ending the session here.